Okay, another polynomial review. I'm running out of packets for this here. Okay. Graphing the equation higher than 3. So we're going to set up our higher than a 2. So you got to use 3, 2, 1, 0, -1, -2, -3. Now let's decide on the arrows right away. Put the very first term, the whole term, right here. And then just set the exponent, negative x to the third, right there. That's negative. That's going down. And that's an odd exponent. So if they're odd, the arrows go opposite ways. So I can expect that to go up. Okay, now everything else is just plug and chug. -2, so 3 to the third, plus 4, and then 3. You can hit caret 2 or second. Plus 5, and then 3 minus 3 minus 10. Okay, -13. Okay, just hit the up key and go replace your 3's with 2's. Zero. Don't freak out if that happens. Just keep going. Trust the process. You already got the equation in. It's going to work. -3. You can put 0 in, but I'm telling you right now the answer is -10. Okay. Okay, then input -2 and then -1 to the third. Because when you're finding the y-intercept, all the x's just go away. They're all zeros. Okay, plus 4 and then -1 to the second. Plus 5, -1, minus 10. Okay, -9. Okay, now I just use my compass. Shout out to the two gentlemen who pointed this trick out to me. 12. If you think it's bad now, before I knew this, they used to have to enter it in every time. They like that. 65. Okay, I'm graphing everything. Okay, so I'm going to go by 10s. 3, -13. 1, 2, 3, and down 10 right there. 2, 0, that's an x-intercept. 1, -3. Okay, remember I'm going by 10s here. 0, -10, so right there. -1, -9, so you go left 1 and then down just a little bit here. Now you're going up 10, 12. 1, 2, 3, 10, 20, 30, 40, 50, 60, right there. Okay, now you just make these and you know what you're going to do. Down, that goes down for infinity as x goes positive. This goes up for infinity as x goes negative. Beautiful looking graph, man. That's the answer to all life's problems. Okay, taking some exponent expressions, simplifying. I'm going to actually look at these 3 at the same time, decide what I'm going to do it. Do you have any plus or minus operators here? That's not a minus operator, it's a negative. Okay? No, you don't, so you're going with the 3 boxes. Look through that. You got any plus or minus operators? Nope. This one gets the job done. Look at this. You got any plus or minus operators? Yeah, you got a plus operator, so you better do the 1, 2 method. Okay? First. All right, now, bases. Underline it, and look at what you got. You got a 3x and y. Don't write x down twice. Okay? So 3 is 1. 1 times -2 is -2. X, you got 2 of those. You got 3 multiplied by -2, -6. And then the other x is on top, so a plus, and then 10. Well, that gives me 4. X to the 4th. Okay, y, 2 times -2 is -4. And that's the only y we have. Now, 3, it's got to move to the bottom. So the 2 becomes positive. Now, the x already has a positive power, so we leave that. By the way, if you moved x to the bottom, then you'd have to make its exponent negative. Why would you want to do that? Okay? Then y goes to the bottom, it becomes positive. Okay, 3 to the 9th can be simplified. It's a 9. 3 to the 2nd, sorry, got ahead. X to the 4th times 9 over y to the 4th. Good. All right, next one. By the way, if you got 2 lines in multiplication, you can just extend them. You can't if it's added, but we haven't added fractions in a long time. Oh, that's coming up second semester, though. Okay, we got number 5. Multiplied by x by y, and then just more x's and y goodies on the bottom. So 5's to the 1, so I put a 1 down. Okay, so x, we have 2, then 8, so 2 plus 8. Other x on bottom, so minus 2, that should be mental math. That's 10 minus 2 is 8. Okay, now the y is a little bit more tricky. You got a negative third on top. And now you move to the bottom, so you subtract a negative 5. Yeah, you don't just subtract 5. You subtract a negative 5. And then subtract a negative 3. You can plug that in on your calculator. That, the minus negatives go plus, plus. Okay? So you got negative 3 plus 5 plus 3. I believe that answers 5 for some of you who struggle with negative addition. 5. So it's y to the 5th. Okay, I think all these can stay put because they're all positives. Okay, so it's 5 times x to the 8 times y to the 5th. Boom. All right, remember, we need to use a different method here to expand a binomial. By the way, what you're like, what's a binomial? A binomial is a plus or a minus of 2 terms. Okay, 2 non-like terms. So you lose the exponent and just make a duplicate, a copy of the same parentheses, 4x plus 2. Okay. Okay, now I distribute 4 to 4x, 4x times 4x. I distribute 4x to 2. I distribute 2 to 4x. I distribute 2 to 2. 16x to the 2nd power, 8x, 8x, and 4. So blank x second plus blank x plus blank. So you get 16, 16x, and 4. I've successfully expanded the binomial. Okay, now we got some equations. Okay, you do have some scratch paper. I'm going to use my sticky notes as scratch paper because sometimes I get cluttered. Okay, what do we have going on with x? You got x third, you got x second, and you got x. So since you have x to all these different powers, you need to find the number of solutions for the highest exponent. So then you got to find all 3. Okay. So that involves factoring to find those. Okay. Finding the x-intercepts is another term people use. I don't like using that, but okay. Now, how many terms you got? 1, 2, 3, 4. Grouping. Grouping right off the bat. Okay. So you group your 2 terms. Then you got your spaces on the outside. Then you got your space. Okay. All right. So more DOPS. Because anytime I'm finding more than 2 solutions, I definitely need to look at that possibility or I'm going to get burned. And it's going to be wrong. I'm going to cry. Okay, so we got 1x cubed plus 7x squared, negative 9x minus 63. All right, so you've got x to the 2nd, 1 and 7, GCF's 1. You can put 1 down there. It's not going to matter. Okay, negative 9 and 63, 9. I will have the GCF calculator ready for you, but for now, going like this. Okay, and that gives me 1x plus 7, and then 1x plus 7. So I got 1x plus 7, pulls out of here. And now I have x to the 2nd and negative 9. Don't write plus negative, write minus, because then you'll think it's a plus and you'll circle it. Well, I want to circle this one. I set that here. Cross those 2 out. And that one's a DOPS. 3, 3, x, x. So I factor that further down, and then I just drop those alongside it. And now I've taken this and wrote it in factored form. So 1x plus 7 equals 0, x plus 3 equals 0, x minus 3 is 0. Minus 7, it takes you to negative 7. Dividing by 1 is a waste of time. Well, you can do it, but negative 3 and 3. Boom. Okay, next one's kind of an annoying problem. You get x to the 6th, man. Okay. X to the 4th, x second. So I have to find 6 answers because I have these other powers of x along with it. So there's 6 answers I need to find through factoring. Okay, but what variation of factoring do I use? There's 3 terms, so that would be GCF. And then my T-chart. Now this one gets a lot of people. One like it because they do 420, 24. They think GCF calculator, and it gives you 4. But then they just put X. Well, the problem is you don't have a regular X. You have X on everything, but X second's your lowest. So it's 4X to the 2nd that you place out here. Okay, and then we're going to place this. Oh yeah, more dots. It's easy to forget, just remember. But you do want to place your GCF factor right there. That's a factor. Okay, then I'm going to divide all these by 4x to the 2nd power. And then the last one, they cancel because they have the same power. That's why you need to do a 2nd power so that these can go bye-bye. Okay, you want a constant at the end. So that is 1x to the 4th minus 5x second plus 6. Okay, now I do the ABC method. So A times C method, that's 6, positive 6. So it's positive, so we're looking for a sum of 5. 1 and 6 isn't it. That'd be a difference of 5. This is a sum. They have to add to 5. 2 and 3 gives me it. Okay. All right, so 5's negative. What's that mean? It means 3 is negative, and we have a positive and a sum, so the signs of the factors have to be the same. Okay, now pay attention to what A is. A is 1 with x to the power of 4. So 1's good, just means I need 2, but x4 is not so good because then I have to go x to the 2nd and x to the 2nd, and then minus 2 and minus 3. Okay, you have a minus, but 2 is not a perfect square, so circle it, delete these. 3 is not a perfect square, okay? So you're going to put those two factors right alongside your 4x to the 2nd. All right, now, this one here can screw people up. You divide by 4 just like you normally would, and you end up with x to the 2nd is 0. But anytime it comes time to square root and I have 0, just put 2 of the solutions as 0. You have a repeat solution. Okay, now the second factor, x to the 2nd minus 2. With the second powers, I might recommend scratch paper, okay? Plus 2, x to the 2nd equals 2. Square root, don't need the I, okay? You can do it one of two ways. You can square root 2 and put 1.41 and negative 1.41, or you can use the board to simplify, but 2 wouldn't divide by anything, so I would just write square root 2 and then square root 2 with negative. But most people are going to choose the decimal. I actually find the decimal to be superior because when you apply this later on to find x-intercepts, this looks better than square root 2. I'm able to see where that would be easier. Okay, then x to the 2nd minus 3, okay? So I add 3. I'm going to have to square root, don't forget that. Okay, don't need the I, so I find the square root of 3. Okay, 1.73 or negative 1.73. You could also use the board, but square root of 3. And if you're using that method, you just put your answers as square root of 3 and square root of 3 with negative in front. But most people are going to select the decimal. It makes more sense to them. Okay, no i's because I never had to square root of negative. Okay, we got a little problem on this first one. This can't be to the 5th. It needs to be to the 4th. You'll see why when I go do the problem. So I've got x. What's special about? Well, it's to the 4th and it's to the 2nd. Well, since it's to two separate powers, we have to find that many solutions for. Okay, so there's two terms. So GCF. And then I go DOPS, a big DOPS box, and then these might be more DOPS. Okay, negative in front, no. But you got x, people just write x down, no. You have a second power x in the end, okay? So 3 and 48, the GCF 3. Because if you just divide by x, you're not going to get the x's to drop out. We can't have that. So 3x to the 2nd. Okay, so that'd be 1x to the 2nd, and that'd be minus 16. Now the reason, if that would have been a 5, then it would have been x to the 3rd. Well, then I can't go anywhere with that because a third's not a perfect square because you can't split it in half. So that would not be good. Okay, so again, parenthesize your GCF, but don't forget about it. And then you keep going. 4 times 4, 1x times 1x. Circle the plus. A plus is never a difference of perfect squares. Now, a lot of people would do 2, 2, 1, 1, 1x. They put 1x, 1x, 2, 2. No. I know that's 2 times 2, and I know that's 1 times 1, but what about x? X without a power. Well, you can't break that down. So that stays. Then I can get my solution. So 3x to the 2nd. Now, I'd normally divide by 3. Still at 0. Now, when it comes time to square root 0, that means 2 of the answers are 0. And this one's going to be cake. You just subtract 4. You don't even need to divide here because it's a 1. You don't need to square root. It's just negative 4. And then the other one would be 4. All right, now the next one, take my advice. Don't try to factor it, because you do have x third, x second, and x. So you got to find the 3 solutions. So you look at that, you think grouping, but I said not to factor. So that's your synthetic division. So we get the first answer and by the way, the dividend is 1, 6, 5, and negative 12. Okay, now to find the divisor, and which is also my first solution, I use trial by error. So 1 to the 3rd, plus 6, and then 1 second, plus 5, and then 1, and then minus 12. Well, okay, 0, sweet. So 1, positive 1 is your first solution. So we divide by that. Okay, 1 times 1 is 1. That's 7. 7 times 1 is 7. That's 12. Okay, 0. Now, what did that accomplish? Well, it took it from a 4 term to a trinomial. So now it's 1x second plus 7x plus 12 equals 0. Because if 4 terms don't factor, I'm in trouble. If 3 terms don't factor, I just have my quadratic formula. I'm not going to need it on this one, but I at least have a backup plan for 3 terms. Okay, GCF of these 3 is just 1. Okay, so A times C, that's positive 12. So it's a sum of 7. Remember, 7's positive. 1 and 12, no. 2 and 6, that's 8. That isn't going to work, though. 3 and 4 is it. Okay. 7's positive, 4's positive. Now think about it. It's a positive with a sum, so the factors have to have identical signs to multiply to a positive. Okay, a is 1, but it is x to the second, so when you make your two parentheses, don't put x second. It's x second now. It goes to x plus 3 plus 4. Set those equal to 0. Get -3 and -4. Boom. Okay, and last but not least, skip the first story. Or no, we have only one story problem. That's good. Okay. A lot of these are repeats of ones you've already seen. These are not easy to make up. Okay. Okay, a video games company profit can be given by this equation. P equals x to the power of 3 minus 12x second plus 35x. So write your equation. Because remember, there's more than one way to make a certain profit. They give you one way, you got to find the other ways. P represents a profit in millions of dollars. X represents the number of video games produced by thousands. Currently, the company is producing 3,000 video games, and they're making a profit of $24 million. What lesser number of video games yield the same profit? So we got to know what these variables mean. P is profit, and X is games, video games. So what values do you get for the money? You get 24 million, but just use 24 for P. 24P and comma, because in that same sentence, it gives me 3,000 for X. But you can use 3 for X. Now you're like, oh, but this is millions, this is thousands. Well, read the problem. P's in millions, so I can just take 24. Video games is in thousands, so I can just use 3. Okay. The point is to work with smaller numbers. Okay, so put those in at the same time. I had a girl, I don't really mention names in these videos, but she did the right thing last week. I made a stupid typing error, and I didn't put it, I had the negative like here, but then the rest of it here. Well, she actually tried it and realized right away it wasn't going to work because she plugged this in and it did not equal what it was supposed to. She was very smart with that, okay? Because she did come to my desk saying, okay, I punched it in, it's not equal to what it's supposed to be. Okay, so that's because I'm an idiot and don't know how to type, okay? Okay, so that works. Now we want to keep it at 24, and all these go back into X's. Okay, now there's 3 solutions, and we already have one of them. 3. Now you want to minus your 24. The constant has to be moved because to reduce synthetic division, which is what the end game, I'm going to want to have 0. So you got 1, negative 12, positive 35, negative 24. Drop 1 like it's hot. 1 times 3 is 3. You get negative 9. Negative 9 times 3 is negative 27. You get 8. 8 times 3 is 24. Alright, so this was x to the third. Now it's a trinomial with x squared, x, and that. Well, I know how to solve this. By the way, a message to some of you. On ACTs, you're not going to have time to do the t-chart. Just use a quadratic formula every time there's 3 terms. Just trust me, okay? GCF here is 1, okay? Not in my class, but... Okay, so 1 times 8 is 8. 8 positive, sum of 9. Well, I can actually figure this out, 1 and 8. So this does factor. I don't need to go to the quadratic formula. So 8's negative and sum negative. Okay, and you get answers of 1 and 8. Remember, the video games are by the thousands, so 3,000, 1,000, and 8,000. They're all those are viable answers.